So first, thank you, ISA, for asking us to be part of this panel, Accelerating IP Development. Uh, I'm going to talk very briefly. There's no doubt in my mind, India is scaling in IP development. I've been in the venture area for last 2 years, and the number of investments opportunities we are getting in services today is very minimal. We are seeing many product companies, be it software or in the hardware space. It is true. I mean, we do agree that the venture capital in the ESDM industry is still very limited. We have a lot of money flowing into the internet companies. We also have some money flowing into the software product companies. But we do understand that there is a very little money that is being pumped into the ESDM industry. So because of this, the ISA worked very hard with the government, and we have a 10,000 crore policy announced. And as Ajay Kumar was mentioning yesterday, these two venture funds, the India Aspirations and the EDF fund, are operational today. So nearly 20 venture funds are put in case with CanBank, and we expect nearly $3 to $4 billion available over the next 5 years for the ESDM industry here. And some of it would go to the fabless industry, some of it would go to the ESDM industry. So this is very motivating because it's set up as a fund of fund, and it will be completely deployed privately. And see, I don't think to this audience we need to iterate, what is the difference, why IP is very important. But let me give a very simple example of a very familiar example of Apple and Foxconn, right? In February 2015, Apple was valued $750 billion market capitalization, which was more than Switzerland, and it had a revenue of $200 billion with a profit of $50 billion. At the same time, the products of Apple, which was made by Foxconn, the revenue of Foxconn is around $131 billion. The net profit was $5 billion, and the valuation, if I am not mistaken, was lesser than the revenue. So it clearly says one company focusing on IP apart from brand is able to get a significant multiples of their profit, while a company which is not focusing or focusing on contract manufacturing services is not able to get that premium. By no way I mean that one is better than the other. It is all different business models. And by the way, Foxconn is a big investor in my fund. And the way in which Foxconn tackles this is the following. So Foxconn realizes this, and what they do is every year they allocate a significant fund to venture capitalists, right? And see whether they can participate in this IP development through venture investments. So, but the Apple and Foxconn story clearly iterates to us, what kind of companies we should start building in India. As Nicholas spoke very well yesterday, we are hoping that the next 10, 15 years we will be able to create many multi-billion dollars company in the ESDM industry from India, right? So with this, let me go to the panel. We all have a theme to talk, and I'm first going to invite Johnson. Johnson is CEO of Granite River Labs. And Johnson's main goal is to help customers navigate a world where connectivity solutions continue to get faster, proliferate, and get harder to implement. Previously, he was Vice President of Business Units in SMSC. Johnson always takes a very customer-centric view of JRL service model and offering. He's bachelor's and master's from MIT and an MBA from Harvard Business School. So I invite Johnson to give the initial talk.
Thank you. Can everyone hear me okay? Okay, great. Yeah, just a little background about myself. I'm, again, Johnson Tan. I'm the co-founder, CEO of Granite River Labs. We help leading technology companies around the world get their products to work together and together deliver a superior user experience. So we started the company about 5, 6 years ago. My co-founder and I, we actually were classmates at Harvard Business School. And we started the company out in Silicon Valley, but we took a different approach in terms of how a typical startup comes about in the Bay Area. We didn't take any venture capital money. It was all self-funded and extremely bootstrapped. And we started the company as we developed the IP. We actually gave the IP away. And you may ask, why would a company in Silicon Valley give IP away? There's actually, maybe we weren't very good business school students at Harvard, but there was actually a method to our madness. So in our business, what we do is focus on connectivity technologies. A lot of interface technologies you're probably familiar with, USB, HDMI, et cetera. I think Cosmic was very active in a lot of those technologies. And the way those technologies come about is that leading chip companies, systems companies around the world, they come together, they collaborate, and they actually contribute IP to the greater good, and they develop a standard that everyone eventually then deploys into their market. So for us, as a bootstrapped, self-funded startup, by working with these companies, contributing our own IP into developing these standards, very quickly we had access to a lot of customers, and that really exploded our growth over the past few years. And by basing our business model on a lot of these standards and connectivity interfaces, at this point we have close to 500-600 customers around the world, which we service through 7 locations, including here in Bangalore. So part of what we always think about as our business is what IP do we want to contribute to grow the pie versus what IP you want to keep closer to the vest and you make money, create competitive barriers to entry. And this is something that I think every company needs to think about with regards to their IP portfolio. We work with many customers that buy IP, customers that develop their own IP, and everyone's really making that decision, what IP to actually create versus to get from some third party. And the main reason for this rich IP ecosystem that we're in is that without this IP, it's very hard to quickly go to market. It's very hard to accelerate getting the customer base, because the customer base is also expecting that you have the complete feature set. And not all features and IP can one company develop. It really has to come together as part of the ecosystem. So what I'd leave you with is just a thought in terms of IP development. It's extremely important to grab customers, to grow quickly in the market. But not one company can do it all. Everyone needs to figure out what their own competitive advantages are, what makes their companies tick, what's their core DNA in the company, and figure out what IP they want to develop and keep to themselves versus what IP they want to contribute to the rest of the industry and grow the overall market. Thank you.
So Johnson is the business manager. You can see we had set a goal that 5 minutes each, and he finished it in 3 minutes. And next we will start with some engineering. Vivek. Next I want to introduce my next panel member, who is Surinder. Surinder is director of SCL, and and he will mention about what is Semiconductor Complex Limited does in India. And he has worked towards implementation of many cutting-edge technology like MMIC, RF MEMS, resonator filters, etc. He has many national and international publications to his credit and is recipient of many awards, including the ISRO's Teams Excellence Award in 2007 and 2012. He held responsibility and project director and led many teams for communication and navigation payloads at Space Application Center, Ahmedabad, before joining the SCL in April 2014. With this, to Surinder.
Thank you. Thanks for the nice introduction. I don't think I deserve that much. SCL, I've been told, particularly by the organizer, that I think SCL being a foundry in the country, but many of us don't know what it is doing, what are the capabilities. So I'll take just a minute on that, as you said, and then probably what we are doing. SCL was originally a public sector unit under Department of Electronics, but Department of Space took it over in 2006. It was a 1.2 micron, 6-inch fab at that time, but seeing the space needs and the other strategic needs, Department of Space decided to overhaul it, and we have put a new line, which is 0.18 micron, that is 180 nanometer, and it's an 8-inch wafer system there. Since then, the fab was put in place by early 2013, and last year, I think from June onwards, we have started producing products from that 8-inch new fab. That old 6-inch line we are using for our MEMS products. We are also a national foundry under NPMAS. We were supported by NPMAS program, which was a national program for smart material and structures. And we are using that old line to deliver whatever our MEMS requirements are there. The fab goal is not to support the space sector. Rather, this is fab is meant for all the strategic and other users also. Space, as the requirements are slightly different, and due to various reasons, we don't get normally the technologies. So we are at this fab itself, we are developing many standard blocks. I'll not say them IPs, but many standard blocks. Because one thing is our requirements are different. The other thing is the performance expected from us is very huge. The systems which are designed are supposed to work for almost 15 years without failing. So it is very much necessary, as is the main aim of making IP cores and IP blocks. So we, keeping in mind our complex requirements, we normally we decide what standard blocks we have to design, and we test them fully. We they are silicon verified, and then we use them for our complex chips. Just to give you a few examples, okay, we are working on all the power management blocks, data converters blocks, data communication units, protocols, various regulators. These fall in very much in the general IPs and general standard blocks, which probably most of you may be working on. But the space needs, as I said, there are special needs. So most of these blocks we categorize into two ways. One is for our normal standard usage, and others are for space needs. So these blocks we have in both versions, normal as well as red hard versions. They have to have the radiation hardening, which is needed for all the space environment. So these are also being designed right now in-house, and again we have now by this time silicon verified many of them at our place.